Should we wait for Shreyash or?
He's not here today.
Okay. Then we'll start. All right, so let me just start real quick. I'm going to share my screen. So obviously there was no class on Monday, so we kind of got out of phase a little bit. So today, my plan was to we'll spend an hour and we'll try and review the lab and the homework. But if we don't get through it, we probably can get through the lab and some of the homework. And then we'll have a little break, and then we'll start on the session 2 slides. So just to remind everyone, the home page of the apps here of the course, and we're going to go into we're in the first section. So I sent out a note earlier. I was just wondering if somebody wanted to walk through their solution to lab one. So just a clarification. So next time we do a lab, we'll do it all together. And because of the snafu that we had when I distributed the lab earlier, we weren't able to do that. But so right now, if does somebody want to volunteer to go through the lab, and then maybe if somebody else can go through the homework, or I can go through it if nobody feels comfortable doing it. But I just wanted to put it out there if somebody's interested in walking through the lab and discussing sort of their results. Anybody who's interested in doing that?
I guess I could.
Okay, great. So I'm going to stop sharing then. If you want, do you want to share your, let's see, so we have the lab directions and we have the lab in our studio. However you want to do it.
Sure. Let me open the directions and then or instructions, I guess.
Cool. Do you want to?
Is it share tray?
Sorry?
Do I open share tray?
Oh, yeah, you click on the little share with the arrow there, I guess. I hope it's shared.
Does this work?
Yep.
Yep.
Okay, let me get down here. There's the warm up. Okay, so for the first one, I just wrote the title and then the date that I did it, and then I knitted that. And so the second thing, the first exercise was what was that? Exercise 1. Yeah, so it does. Okay, so for the first one, I just first I loaded them in tidyverse and library datasaurus, and I went to exercise 1, and when I in the directions it said the frequency table you did, and with the frequency table it wrote that it was like this many entries, so I think it was 1846 rows and 3 columns. Is that correct?
Yeah, I think you got that though from the question mark, right?
Was that where you guys got it from? I don't remember.
I think so.
Okay. And then exercise 2, it gave me the figure height already and the figure width. And so basically I just have to plot it. So I made a dyno data thing, and that takes from data source doesn't. So there's this symbol, and that pipes into a filter for the data set, and then dyno is just the name. And the plotting I also took from the lab directions, and the correlation I also took from that. And so for exercise 3, I took the same code, I copied and pasted it, but then I changed it to plot star instead of plot dyno. I pasted the width and figure height too, and I made it star data instead of dyno data. Same data dozen, and the name was star. And I also plotted it with star data instead. So I switched this as well. And the correlation, same thing. I did core star instead and star data. Does this look correct so far, Mr. Abdu?
What can you knit it and can we look at your output?
Yep. Does it come up?
Oh,
No.
yeah. If you where do you have the are you
You can go to little gear and change it to
displaying it
show up in the plane.
in the preview pane? Yeah, if you go to
Oh,
your
okay.
gear next to it, yeah, go preview pane. Yeah. Viewer
Okay.
pane. Yeah, and then maybe
So it's got
maximize
plot.
the right hand side. Yeah.
Um,
Can you
like this?
there's a little on the right side there's there's two yeah, big and a small. Yeah, that one. You maximize that.
Okay.
Cool. So one of the things that wasn't super clear in the lab actually was the correlation. So what was the correlation on the first one? The correlation coefficient?
Negative
0.645.
0.0645 appears.
Yeah, and then on the exercise 3, what'd you get for the correlation coefficient?
Just 630.
Minus 0.630. Yeah. So this should have been exactly to really illustrate what they're trying to show, that it should be exact, but the data isn't exact enough for the correlation coefficient to be exact. But so let's keep going. We'll talk later about the correlation coefficient and the other summary statistics, but that looks right.
Okay. And then I just wrote that it was less negative than Dino because that was one of the questions. And for exercise 4, it's applying the circle. So I did the same thing again. I just copy and pasted same figure height and width, and I used circle data instead, and I named it circle. And then when I was plotting it, I copy pasted that, and I chose circle data instead, and I used the geom points. And the correlation, same thing. I used circle data. The one thing I wasn't sure about was, do we need to name it something like core circle?
You don't have to name it, but if you do name it, the names have to be unique. But they're really just naming the chunks.
Okay.
Yeah. So if you go down, so show us what the output exercise for us is. It's a circle, so that's cool. And your correlation coefficient is point minus. Okay. Yep. Cool.
Okay, and then plotting all points. Yeah, I didn't understand facet wrap, but this is how you were supposed to do it, I guess. And for the comparing, it was a summarize, and then printing that. I don't know if I did the comparing right, but it did plot all of them.
Yeah. So let's talk about that just a tiny bit. So yeah, go back to the facets. So first of all, facet wrap is displaying so a facet is one of those little tiny graphs, and when you facet a data set, you're going to graph a bunch of you're going to graph the whole data set where the some variable is going to separate the data out, and the data separation thing is called data set. It was a little bit misleading, but so the data set is in the title of each of those facets. So the first one's called away, second one's called bullseye. And so that's what the data, so if you look at the actual data table, it's like the first row is called data set, I'm sorry, the first column, and there's lots of entries for away, and then there's lots of entries for bullseye. And for each of the away entries, there's an X and a Y, and for each of the bullseyes, there's an X and a Y. So that's what facet wrap is doing. It's saying, show me facet graphs with the dataset variable in each of the facets. Not sure if that's super clear, but the actual coefficient code, I wish we had gone over this in lab, but on line 96, I think that there's a little bit of there was a typo. So that 13, if you delete, can you delete that 13 on 97? Just delete the 13 in there. Yep. Oh no, and then open close the parens. Yeah, you can say print and open close, but not the 13.
Okay.
Yeah, reknit that.
I have a question also about the facet.
Okay. Well, so let's just finish this quick though. So, yeah, go down to the bottom, and what you'll see is the correlate. So if you just print the summary with the correlation coefficient, the idea the illustration was that those correlation coefficients should have been all the same or very, very similar. And so that and part of the point of the lab is that you've got these very, very different graphs, but the summary statistic is pretty close. And the idea is that you really have to visualize the data, because if you just look at the summary statistics, you might make the conclusion that all the different graphs would be the same, or the data is all the same. Actually, I'm going to, let me just give you a replacement on for line 97. So here, I'm going to put this into the chat. Replace line 96 with this line here. And what that'll do is that'll show you the mean value of X along with the correlation coefficient and Y. And then we can look at that data really, really quick. Yeah, reknit that. Did it not like it?
Oh, there. Yeah.
Okay, so the mean value of X in all these data and the mean value of Y are exactly the same. So if I looked at these data and I didn't have the visualization, I might conclude that, oh, the mean of X and the mean of Y are all the same, so the data must look the same. And the point is that they can be very, very different, even having the same, very similar summary statistics. I don't know if that's helpful or not, but that's a little bit.
Yeah, that makes sense.
What was the question on the faceting?
Well, if you just go up to your facet thing, yeah, so I don't think that figure height does anything. It's just, you know, that's just a name for it. I don't think that you're actually setting the figure height there.
In the line 85?
Yeah.
I think that this one actually takes precedence over the global one. But you can play with that and see, like, if you change that figure height to 10.
Isn't that just the name of it?
No, that's not the name. Those are parameters of. See, there's a comma after the R, and then.
Okay.
Yeah, those should be parameters, and so the figure height should be twice as high now. Takes a minute.
It doesn't look like it looks the same, and I didn't do that.
So
It made it a little wider.
The exercise goes further, and you click on that little gear thing, and you can change the height and width. So that probably adds those parameters if they're not there.
Well, there's a global parameter if you could.
Right.
Oh, actually, can you go to the top? Did you guys do that part of the exercise?
But there's also a local parameter for each block.
Yeah, and that overrides the global parameter.
Yeah.
Okay.
But
So it probably also inserts those in there if they weren't there.
If they weren't there, it would just make it the global parameter with default, I guess.
Well, it looks so. If you go to the top, I don't know if you try to do it with that GitHub document, it'll give you an error. I think it's like go to the gear right now. I think if you go to output, you don't even have output options. Do you have to click on visual to get that? I can't remember. Some people had problems with that.
I have it. I don't know.
Click on visual quick, right there next to source.
Next to
source underneath, yeah. No, yeah, get out of that menu and go to there's visual next to source, right to the left of where you're pointing.
Right to the left. Oh, yeah.
Yeah, that guy. Okay. And then see if that pops it up. Go back to the gear. It takes a minute. Okay, use visual mode. Yeah, you can say use visual mode. Yeah, now click on output options. Now it should fail if you click on output options. Yeah, because the YAML, the YAML is the text between those dashes, the title, the author, the date, the output. Click on OK. This is another strangeness of the lab. The output called GitHub document is an unknown output type. So if you replace GitHub with HTML, then it'll start behaving a little bit better. Yeah. So knit that. Oh, you might have to install something. Sure.
You can do it under output. Also output
Oh, it
format.
still works. And then I do output
Yeah.
options.
Yeah, so
Yeah,
you could
now
also
you
do
can-
HTML. Yeah.
Yeah, you can play with your figure heights here. And if you do that one, yeah, if you just set it to some setting and hit OK, then you can see that what it'll do is it'll stick those options basically into the YAML, which is this
Oh, nice.
text at the top, and that's the global setting. So that little dialog that came up is basically just a fancy way to put some text into the into that space there. So
Okay.
yeah, so like if you have if you've got, well, here, knit it and then we'll see what happens. And my guess is that all of the figures are not going to change. They'll all be the same. So yeah, so they haven't changed. Oh, so what?
Yeah,
I'm
mine
actually-
all changed because I didn't have it in that.
You didn't have the
Top line.
override. Yeah. But if you change your figure width, say, and your height to 1 and 1, to just like to make it look at really extreme, right? So change it to 1 and 1 and reknit. And my guess is that it won't change, still won't change your output.
Yeah, because it's overridden. Yeah.
Yeah. But now go down to the Dinosaurus one, that first graph, and get rid of those figure height and width bits. Yeah. Just down to back to the comma, including the comma. Yeah, and reknit that. Now your dinosaur will come out tiny.
Hopefully.
This is my guess. I will predict. Tiny dinosaur. Yeah, so the figure, if you have the width and height, that overrides the global setting. And so that's just how it works, I guess. So cool. Was there other stuff? I think that was pretty much the extent. So did everybody get through that? Were there any challenges in this one or questions? Okay, great. All right, well, that was cool.
Sure.
Yeah, thanks a lot, Shamil. Appreciate that. So that was the lab. Now, I'm not sure how many people got through the homework. Some of you did. Does someone want to take a shot at walking through the homework? If not, I can walk through it quickly. All right, crickets. I'm going to walk through it. So here we go. Ready? I'm going to share my screen. And I don't know, this will probably be super tiny, probably for you.
Did everybody do it?
Was everyone able to get through the homework?
Yeah.
Anybody not able to get through the homework? Okay. Well, if you can see my screen, tell me if you can't, like if it's too small, but I'm just going to walk through the homework.
One thing that I found odd is that in the repository, I can see Grace's as well.
Yeah.
I know, I found everyone can see Grace's and I don't understand why. She said she didn't
Okay.
change anything.
All right.
Somehow her repos became public or became visible to everyone, and I don't know how that happened.
Okay.
I'm going to go back in probably, just like my guess is she added permissions somehow to you guys, because nobody else's, you can't see anybody else's, right?
No.
Yeah, so not quite sure what happened.
Okay.
Okay, so this is pet names. Goal of the assignment is to introduce you to all these things, our Studio, Git, and GitHub. So was everyone able to commit and push their changes back from lab 1 because you needed to create your personal access token, which wasn't initially in the lab? I think everyone got through that, but I'm not sure. If you need help, let me know.
Yeah.
Cool. All right, so prerequisites, blah, blah, blah. This is all about R and RStudio. Hopefully we know about that. I am going to go down to the actual assignment. So you were able to check out your homework by going to your GitHub, copying the repo, opening it in our studio. This is a recap of the different parts of our studio. I don't know if anyone did type the 2+2, but I'm going to do it. So on the bottom left is the console, and that's where you can do programming. And you can do programming things like 2+2, and it'll tell you 4. So that's super cool. The bottom right is the files pane. So let me just recap these things. So the files pane, if I click on files over here, I see the file. I've already opened it in our Studio Cloud. And I can click on the RMD, it's already open. And then on the top right, you can see the environment. And in the environment, you can see if you've executed anything in the console that this data shows up. Now, I want to just reinforce this. If I delete everything in the console here, and I'm going to delete all of my objects, and then I'm going to knit my document, you should see that nothing shows up in the environment. There's nothing in the global environment, and that's because all of the execution is happening in this other special knit environment. So it knit the data, but it didn't do anything in the environment. But if I want to actually execute this stuff and have all these data show up in the environment, I can go over to the run dialog here. I can click on run, and I can run these guys one at a time, or I can just run everything. I'm just going to run all, and it'll put a few things into the global environment as it runs it. And you can see on the bottom left that it executed all of these little sections of our code. Give me a warning. But then this plot SP, which is I guess the only thing that actually is created during all of running of all these, yeah, here it is, plot SP, goes into the global environment. And so if I add anything to the environment, it pops up here, and I can click on it, and then it'll bring up that data. So that's just a little bit of an aside, but it's a helpful thing if you run into problems, you want to maybe exercise them in the console.
I mean, the handy thing that you shared with me is that you can just click on each of those chunks.
Yeah, or I can do, right.
So you can run, if you want to just, if you have an error and you're not sure where it is, you could just go through chunk by chunk and run it.
So I can, yeah, I can load my libraries by just clicking there. I can do this Seattle Pets thing by just clicking there. And the output of that goes into the actual top left pane in the RMD output. I could also, what's that, Pete?
Sometimes I noticed it didn't add stuff to the environment unless I ran that chunk separately. Does that sound right? I don't know why it didn't.
Well, the built-ins, the built-in, so Seattle Pets is a built-in data set that's part of I think Open Intro. It doesn't show up. So if I wanted Seattle Pets, I would have to say view Seattle Pets, and for some reason I don't know why it doesn't show up in the global environment.
Yeah, I think the last some of the problems in here were kind of tricky because you couldn't view the whole data set you created. So I had to make new data sets.
Oh, okay.
And I couldn't view them unless I ran that chunk separately anyway.
Interesting.
I don't
well,
know.
let's see if we can get there and
yeah.
Not quite sure. Okay, so we talked a little bit about the environment pane. Okay, so here's an exercise. Try typing X is 2 in the console. So for those who have done programming, and even not, a lot of the time, the assignment operator is the equal sign, X equals 2. In R, it's this funny left arrow thing. So I'm going to say X left arrow 2, and then you can see that X pops up into that global environment. So anytime you do an assignment down in the console, it pops up in the environment. All right. So I'm just going to go through quickly on this guy. So I changed, let's change my name to my real name, and it's the date, and then I'm going to knit, and I will see that that updates to my name and the date. Step 2, oh, my commit. So I could go and I could commit this, but this is actually Jackie's project, so I'm not going to commit this one and push it because that would override what she's done. I didn't have my own project, so I used hers. So I'm not going to commit.
Okay.
So this is a local copy. It has, you'll never see any of these edits, but unless I commit them and push them back, and then it'll blow away your changes. So we'll do that. But everybody knows you click on what you want to, you click on this guy, which isn't super clear, and then you go to the commit guy, you type a comment, you hit the commit button, and then you push. That's the pattern that we'll do over and over and over. But I'm not going to do it. Okay. And yeah, we talked a little, the lab talks about when you should do a commit. So like if I was doing this and I wanted to save my changes, every time I did an exercise, I would do a commit. So that means if I screwed up on exercise 4, I could back up and delete the changes back to exercise 3 where I did my last commit. You don't have to push them, but you do have to do the commit, and then you can undo them as you go if you need to.
So
And the push.
there's
Yeah.
something else you have to do too in there after you commit. Each of those blocks you have to, there's a little, the diffs, you have to accept the diffs somehow. What's that called?
No, you just have to commit it. You can look at the diffs, like here are all the
Oh,
diffs.
see that
Oh,
little
staging.
box?
So staging, right?
Yes, staging.
You got to click the little stage checkbox,
For
otherwise it
each
won't do.
chunk, right?
Nope, just for the document, for whatever the document changes are.
Oh, you can do that little thing? Okay. I didn't know that.
Yeah, and so so I haven't done any commits. You can see all of the diffs. You know, the red ones are deleted and the green ones are added.
Okay.
And you can just like this would be like a big, and a lot of the time if you're lazy, right, it's all my changes, right, are going to go into one commit. But then if you do that, you can't, it's hard to back it out.
Yeah.
So
okay.
I was serious of it. So you do the commit and then you do the push, and when you push it, it takes your local copy of the repository and it pushes it back to GitHub, and then I can see the changes that you've made, or any other collaborator can. Okay. Packages. Okay, so it asks you to run this chunk, right, using that little green arrow. So I'm going to go back and do that. I already did it. Well, I'll just do it again. Usually you'll get a little warning, a bunch of information. Oh, the message is false. That means I don't want to see messages. So if I delete this, well, the library is already there. But if the library wasn't there, I think I can kill the environment. If I delete the environment, I think it will. No, it's already imported it. Anyway, that's what that messages equals false is if there's messages after you execute this block, this suppresses those messages if you don't want all that stuff to show up in here. And you can do the same thing with warnings and errors. It's not a great idea to suppress them unless you really know that the warning is not useful. Okay, let's look at the data. So the city of Seattle has an open data portal, has a lot of pets in it. So this is the thing that I just did before, view Seattle pets. So I'm just going to copy that. I'm going to close this guy, and I'm just going to paste it in here. I'm going to view Seattle pets. I put that in the console, and now the Seattle pets pops up, and you can see that this is 52,519 rows and 7 columns. And I think that might be exercise 1. Oh, and the data dictionary. So if I want to know a little bit about Seattle pets, I can do this with data sets that are built into libraries, and I can also do this with functions. It's more interesting with functions, but the names, so if I did a help on Seattle pets, and it tells me it's a data frame with 52,519 rows and 7 variables, and then this is the data dictionary. If you wanted to know what a data dictionary is, that's what this is. It tells you what all of the columns mean, something a little bit about them. So exercise 1, according to the data dictionary, how many pets are included in the data set? Well, let's go back to my viewer and see if I did that. Exercise 1. Oh, I got fancy. So instead of you could type in 52,519 and knit it, and you would get the right answer. Or you could be fancy and you could put in a little bit of R snippet that says count the number of rows in the Seattle pets data frame and knit it, and you'll get the same answer. But it's kind of fun if you have a data set and you don't know how many rows it is and you don't want to hard code it, you would just
How
get it
come
out.
how come you can do that without having the 3 dashes and like a
Yeah,
chunk
is-
block there?
it's a different way to put. So there's a lot of restrictions on this inline execution stuff. It has to be a single expression. And so it's not multiple rows, and you can't do assignments and stuff like that. But if you have a single expression that you can express through a pipe, some piped stuff, you can put it in here. It's pretty limited, but it's nice for this kind of thing. I want to count the number of columns or rows in a data set. But it is limited in what you can do. It's just a nicety, really, but it's kind of nice to use. Another way to do it would have been, I could have done, I could say, I could make a block here. And then I could say, rows, SP size, right? And then I could put this code in here. This doesn't really help a lot, but if I executed that, now SP size is there, and I could say SP size. And that doesn't really help, does it? I didn't like it either. Anyway, okay, forget that. There's a that didn't help, so I guess ignore it. Let's go on to exercise number 2. Okay, so this is asking how many variables. So that's confusing a little bit. A variable in this context is the same as the columns. The columns are interchangeable with the variables. So that would be like how that tells me that there's 7 variables in exercise 2. You could have written a 7 because you looked at the data dictionary, or you could have gotten it out of the data set. I'm going to go to exercise 3. Okay, so what are the 3 most common pet names in Seattle? Okay, well, it tells me how do I do this. I say Seattle pets, and I pipe it to a count of. So I'm piping this data frame Seattle pets to count, and it's counting animal names, and then it's saying sort them. Okay, and so if I do that on line 31, I can I can execute that. Or I can just put it into my knit. And it's sorting it in descending order. And so the top ones are my most common ones. And if I execute that, I can look and see that the top 3 names are NA, Lucy, and Charlie. And I spent a few minutes to figure out, actually, you can do an inline expression, but this is too complicated to do. And so what I should have done is just write common pet names are, and then I'm just going to look at this data table. It's NA, Lucy, Charlie. That's exercise 3, and this just shows me the data table after doing the counting. So these are patterns that we're going to see over and over and over. We're going to pipe a data set into some filter or a counter or a summarizer or something like that. Oh, by the way, do you guys get what these icons are? So what's the first icon? Anybody? What's it look like?
Record? I don't know.
It looks like a ball of yarn.
Knit.
Yeah, and then the second is
Push.
Yeah, the second one is commit, and the third one is push. That's what these icons mean. Knit, commit, push. Because I think they're just it's nice. So what they're saying is every time you do an exercise, do that knit, commit, and push it as soon as when you knit it and you get the right answer. All right, so now let's look at the next one. Okay, we're going to look at the next. Okay, this got a little confusing. They're going to look at the next common pet names for various species, and we're going to use group by. and we're going to group by species to do a count of the pet names for each of the names, but on a per species basis. So that's what this code's doing, is I'm piping Seattle pets to group by species, and then for each species, I'm counting the number of entries that have the same animal name, and I'm writing out for each animal name, for each species, what are the number of entries in the data set. So let's see, that's this guy. I got a little bit ahead of myself, I think. So I could just do that count and I'll get this data out. But that, and then it goes on and it says, well, gosh, it's not what we wanted. What we really want to know is like, what are the most common cat and dog names? And so we want to do this extra thing, which is, well, before we do that, we're going to count just on species, and we don't care about the names. And so if we did that, we could see that there, there's 35,000 dogs and 17,000 cats, and then there's some goats and pigs. Just run that quick and see what this is. Yeah, so that's good. So that's if you just want to count by species, the number of each of the species, but that doesn't help either. What I really want to do is this thing called slice max. Now, some of these things, if you want to do a thing and you want to like figure out, sometimes you just got to Google it. Like I would not have known that slice max was the right thing to do, but then you're like, I want the top 5 entries of something. A lot of the time, Stack Overflow will give you the right answer. But in this case, they're giving you these guys to do. And if you execute this, you get this result, which gives you exactly what you're looking for, which is what are the top 5 cat names and the top 5 dog names, which is like what the question asked you to do. And then exercise 4 is a little bit confusing because it says it's not what we asked for, but I think it is. And then they said, well, use a range to do that. And it turned out when I did it, I didn't have to use a range in order to get the right answer. So, and I Googled around on a range, and it looks like a range has changed its meaning a few times, like in tidyverse. So I think this may have changed what it's supposed to do. I don't know if somebody got something different, but you can get the right answer without having to arrange the data differently, which is like understanding, you want to figure out whether the top 5 cat and dog names, and that's what these are, and they're sorted, right? You've got 400, 100, 186, so those are sorted in decreasing order for cats and for dogs. So that's a little bit of a snafu for this exercise. Anybody have any questions on that?
Yeah, I kind of got hung up with the arrange, and
Yeah.
I did the arrange both ways, and then I realized you can't do slice max because it kind of overrides arrange.
I think it does. Yeah.
Yeah. So you got to take slice max out and do arrange, but
Oh,
then
did you get it? Yeah.
then it lists basically the head of the table are all ones,
Right. You get the goats.
So
right.
then I had to make my own data sets, and then I had to figure out how to view them to get the answer.
What'd you come up with?
I got a range. Oh, I have to look. Arrange species /n organizes the output by species, then ranks the names in order of frequency. So
okay,
that's what I got.
And that's the same as the way the slice did it, right?
Well, no, it's backwards here. Like I just did that. Did you do a sort descending in a range?
No, I didn't. I couldn't figure out how to do that, so I just viewed the whole table and looked.
Oh, okay. So
I viewed the whole data frame or whatever the result was.
All right, so so let's look at that then.
It was confusing because if you look at the head or tail, it really doesn't show you the whole story, right?
Yeah, there's so many ones.
The ones, yep.
But actually, if I click here, I should be able to sort this by high to low. Yeah, but it does. You lose your group by when you do a range, and that's one of the things that it said in the help.
Right. So you have to scroll all the way down and look, basically.
Yeah,
satisfy
really
yourself that you did it right.
I think it doesn't help.
So yeah, it wasn't a very.
Well, what if you arrange the other way? Then doesn't it group by the dog first?
No, it throws
No.
away the group by. That's the problem.
It throws away the species. It just doesn't.
Oh,
And there is this by group equals true thing, but it doesn't do anything. Like by group equals true in a range supposedly keeps the grouping, but it doesn't work. So this you're going to run in. We run into this
Yeah.
sometimes, and things kind of just don't work the way you expect them to, and then you got to try something else. No, here's a descending. How do I do descending? Use desk.
I
to
couldn't
sort.
figure that out because every time I did it, it screwed it up.
Okay.
The species. So once you
What
do
if I-
descending, it messes the species up.
It does. All right. So look. So
Unless
I
you might be able to figure out a way to do it. I couldn't.
doesn't even like it. Anyway, the right answer, you can get the right answer by just using slice max, and so that's what I ended up doing. Is because you don't need to do anything else because it gives you those data. Anyway, so that's a little bit of a snafu, and I apologize for that. Something is wacky, but okay, let's go on quick to this last one. So basically, this is a visualization. It's a little bit complicated how you get this. You can actually see it if you want to by finding the R markdown that creates this page. And if people are really interested, we actually can go there and look at what they're doing. It's kind of cool. But let's just do this for right now, which is it's saying, oh, this is visualization, and it's plotting the proportion of dogs with a given name versus cats with the same name. So the x-axis is proportion of cats. So it's a name, and so for example, Lily has 0.005% proportion of cats names, but the y-axis is a proportion of dog names, and so the name Lily is 0.004 proportion of dog names. And that's kind of, this is how you read this. So each dot is a name, and the position of the dot tells you like how many cats were named that and how many dogs are named that. And if the same proportion of cats and dogs for a given name are for a name, then they would lie on this line. So Luna almost has exactly the same proportion of cats and dogs because it's very close to this line. Same with Max, Milo, maybe Oliver. So here's the 20 top most common cat and dog names. And the diagonal line is x equals y, like you just said. And so the exercise says, what names are more common for cats than dogs? Well, what names are more common for cats? Well, here's the cat proportion. So which names would be more often named for cats than for dogs? Anybody?
Oliver.
Lily and
Oliver.
Oliver.
And Lily, correct. Yeah. Yep. Because they're on this side of the line. So there's more cats than dogs. And then the next one says the ones above the line are the ones below the line. So there's two questions. So the names that are more common for cats than for dogs are the ones that are below this line. And then exercise 6 is the relationship between the two variables, proportion of cats versus proportion of dogs with the same name, is this a positive relationship or a negative relationship? And so to figure that out, you would say, well, is for a given name, are there more cats and more dogs, or are there some names where there's more dogs are named it, but very few cats are named that? And so, we have to squint at this a little bit because it's not a super clear relationship. If I look at Daisy, many more dogs are named Daisy than cats are named Daisy, right? There's 0.006-ish for dogs and 0.002-ish for Daisy for cats. But a lot of them, as you kind of go, as a name goes up, it kind of goes up for dogs and for cats. So I would say, well, it looks to me like it's a positive correlation. But you could say, well, gosh, these are outliers and they don't really count. You could get rid of, if you got rid of these high numbers, you might actually find yourself with a negative correlation where, Daisy's high for dogs and low for cats, but Oliver is relatively higher for cats. Not really, it's about the same, cats and dogs. So it's not super clear, but it is, if you actually do the math, it turns out to be sort of a fairly, not a strong, but a positive correlation. So yeah, that's it. I think that's the exercise. So, I'm not going to commit it. Any comments or questions on this? Did people find it difficult or relatively straightforward? I know there were a couple of gotchas there, but apart from the gotchas.
Yeah, just confused by the wording of some of those, like the last question, but I understood it in the end.
The wording was confusing.
Yeah.
Like, what does this mean in the context of the data? Yeah, I'm not quite sure what that. We know that. Do you agree that it's a positive correlation?
Yeah, that's what I put. I put it more like I'm thinking about the slope of the line, and that it's independent of the species. The names, the popularity of the names is independent of the species, more or less.
Well, that would mean that they're the same proportion, right?
Yep. If it was a negative slope, it would be dependent.
Well, it'd be interesting to actually do a regression fit to this. So
Yeah.
We don't do that.
But you're right, though. If you threw out those 4, it would
Yeah, we
turn
did
negative.
that.
What's that?
Yeah.
We did that. You probably have to you have to throw out more than that. You have to throw out the 1, 2, 3, 4, 5, probably those 6.
Yeah, it's a positive 0.6
Oh,
correlation
it's
with
still
everything. No, if you throw out those high ones, Lily, Max, Bella, Charlie, Lucy, it becomes a negative 0.2 or
Okay.
something.
Yeah.
Which is kind of interesting. Which is Simpson's paradox, which we're going to talk about a little bit. So timing wise, I think this is actually very good. We got through the lab and the homework, and I think maybe we should go to break now, and then let me just bring back our little schedule. What I wanted to do is in the second hour go through, maybe not go through. So there's I think 4 or 5 decks. So maybe we'll go through 2 decks, and then see where we are after the break. And then next week we would sort of finish with the slides and then talk about the application exercise in the lab and then discuss the homeworks. That's kind of what I was hoping to get through. So why don't we go on break now for 10 minutes and let's come back at 8 o'clock. Does that work?
Sure.
Okay. Cool. I'm going to go on to mute. Bye. Raise your hand when everybody's back. Swing, swing. Cool. Is mommy back? Let's do that. Oh. Let's wait a second for Shamil. If I do that, does it do that? So while we're waiting, actually, can everyone just validate that they have gotten homework 2 and lab 2? You should have gotten those. They should have shown up in your GitHub. I don't know if you get an actual notice or not. I don't think you do get an email or anything.
Yeah, I got him.
Okay. Sweet. If you got it, everyone else probably did too. Can you see Grace's?
No.
Okay, she must have put something on. Or maybe I did that. All right, cool. So everyone got that. Should we wait for Shamil, Lucas, or? All right, maybe I'll keep going. So like I said before, so this might not take a whole hour, but I think I would I'll go through 2 of these sessions, and then we'll finish the slides next Monday, and then on the Wednesday after we'll do an application exercise, lab 2, and then we can talk about homework 2. But if you guys want to, you have lab 2 and homework 2 now. You can start playing with it. I haven't done it. I'm going to do it on the weekend. So I'm going to play. So this is week 1. We're done with week 1, guys. We're going on to week 2. Week 2 is all about visualization and ggplot. It's pretty cool. So I guess I'm just going to jump in. So we're going to go through part 1 and part 2 today. And we're just going to step through these slides. And I'll get them to the right size so that you guys can see them in that display. Like, is that a reasonable size there? Or should I make it like I can share just the frame? Maybe I'll do that. Friday. Let's see. I'm going to share just the slides. Let's do visualization. That's good. So can you? Is that good? Is that easy to see?
That's fine.
All right, I'm going to start right in now. So we're talking about visualization. Okay, well, first we're talking about a data set. So what is a data set? Anybody? Somebody tell me what a data set is.
A set of data.
It's good. Yep, and more specifically, it's like a 2-dimensional table like you see in Excel. That's kind of what people say. So people call it different things, but it's generally, and this is the tidyverse way to do things, every row is what we call an observation, and every column is a variable. And so there's tables and there's data frames, and they're all data sets. they're all different. They're all pretty similar, and we'll talk about the difference between tables and data frames a little bit more. But they're all basically representations of this two-dimensional stuff, data, like you'll see in Excel. So there is a cool data set in Tidyverse called Star Wars, and Star Wars has Star Wars characters in it, and it's basically just a sample data set. But the Star Wars data set it's a tibble, which means it's a Tidyverse data set, and it's got 87 observations, 87 rows, and each row is a character in Star Wars, and then 14 variables, so 14 columns in this data set. And you can see that the 7 variables are the sex, which is, and the type is also part of it that tells you. So the sex is a character string, basically. Gender is a character string. It's like a name or something. Homeworld, species are characters. And then films, this is kind of a difference of what a tibble is a list. So you can actually have an entry in an observation that's a list of stuff. And so in films, you're going to get all of the films that a given character is in a list as an element of one observation. Let's go to the next guy now. So here's Luke Skywalker. Here's Luke's data. And he's got a height, and he's got a name, and he's got a weight, all this stuff. And these are all aspects of Luke. And here's the list of films that Luke Skywalker is in: Empire Strikes Back, The Revenge of the Sith, yada yada. And this is kind of cool. Like in Excel, it's a little bit cumbersome to do this. You can actually do this in Excel too, but it's cumbersome. And then the vehicles and the starships, those are all lists of things that they've, like the vehicles that he's driven or the starships that he's piloted. So if we look at the data, and we can do this, maybe should we go ahead and do this? Well, you guys can follow along if you want. If you want to open up R and exercise this guy. I'm not going to do that right now. But you can, I'd say go through later and do it. Unless you want to do it now, I don't know. It'll take longer, so let's not do that. But there are certain like commands that you can do to sort of see summarizations of a data set. And so glimpse is one of them. It gives you kind of like,
I mean, how do you just like play around in art? Like, how do you make like a blank space? Everything we've done has been a git repo. You
Okay,
just make a new project. Okay.
let's do it. Let's go do that, actually. I mean, that's a really good idea. It takes a second. So I'm not going to do our markdown here. So this is a little bit unorthodox, but what I'm going to do is I'm going to do a little plus guy here. I'm going to just do an R script. And an R script is just R code. I can't knit it and make markdown and make a live document out of it. What I can do, I could just write, I'm sorry, is it times time? So if I do that, if I run that, it probably won't like it. Yeah, so I have to install packages. I'm just bootstrapping here quick. And then we can run a couple of these things. So this is just installing the Tidyverse, which is a big guy. You guys could do this on, if you want to start one up, or you could just watch. It's taking its bloody time, isn't it? I'm gonna execute the library, so that brings it all in. And now I can look and see. Well, let's see if Star Wars is in here. So let's go back here and let's go back once. So if I just do Star Wars here, there's my tibble. so if I'm going to put it in my R script because if I do it in the console, I've kind of lost it and I can't do it again. So I can execute Star Wars because it comes with Tidyverse. And that's what I'll see. I'll see this output, which is basically just sort of the top 10 observations of all of the 14 variables. Or I can go and I can do this glimpse. If I do a glimpse command, it's going to look at, it's going to give me, it's going to slice it slightly differently. It will, for all of the columns, for all the variables, it'll give me the first few samples. So that's kind of turning it on its head a little bit. But sometimes it helps to look at it that way too. So I'm just going to copy and paste that into my R. Tell me to stop if none of this is clear. But I'm just basically, I have an R script and I'm just going to copy and paste things into my console and we can see the output. So if I use glimpse, I can see that there's these 14 columns are sort of sideways instead of if I just typed it out, the variables are across the top and my observations are rows, but the glimpse is backwards. But it's another way to look at it. Let's keep going here though. Okay, well, so again, if I want to know what's in a data set, if it's a built-in data set, I can get this information. If I make this data set up, I can't get this information. But since somebody went to the trouble of writing this this help file, I can run it. And I'm just going to hit the run. What I'm doing is I'm just like clicking on line 7. I can also highlight it, but I can just click there and I can hit the little run guy here. And then it pops it up into the help. And so if you want to know what a function does or if there's data, then you use this. Like if I want to know what a range, how to do a range, right? I can do the same thing. And if there's something exists, it'll pop up over there. Okay. Anyway, so here's any of these data set. Sorry.
Sorry, but for me, glimpse isn't showing up as a function, and Star Wars isn't showing up as like.
I'm sorry, I did it. So did you have to do this guy in order to get any of that stuff? Install.packages and then in quotes tidyverse.
I
install
it.
Okay, and then you have to execute library tidyverse, which will actually import the library into your environment.
Do you just have to run that?
Yep.
Okay.
Does it work for you?
Yeah, thanks.
All right, so we glimpsed. We got the help. Now we can look at some of the summary statistics of the data set, like high level, like how many rows and columns does this thing have? I'm just going to go and do these and we can play it. These are you're going to get to know these so well that you're not going to have to like go back and copy paste them from places. But at the beginning, let's just copy paste. So I'm going to run n row, which is the number of rows. How many rows? 87 rows. How many columns in Star Wars? 14. Cool. And then dim gives me the dimensions of the data frame, so it's going to give me both at the same time. Dim Star Wars gives me both 87 rows, 14 columns. So that's just different ways to figure those things out. And now, okay, we're going to talk about exploratory data analysis. This is kind of what this whole course is about, but we're defining it here. So basically, we're going to analyze the data sets, and then we're going to summarize the main characteristics. And a lot of the time you're making pictures because the picture really is incredibly valuable in terms of understanding what the data is doing and what's it saying. We might also calculate summary statistics, right? We calculated correlation coefficient and the means of X and Y before, so those are summary statistics. We might do some kind of manipulation of the data to group it or transform it or filter it before we do visualization. And those are the things that we're going to look at. So the first thing we're going to look at is understanding how to visualize, and then we're going to look at how to do wrangling and manipulation. Okay, so here's a very simple visualization of the Star Wars data set of plotting height and weight in a scatter plot, right? So height is on the x-axis and weight is on the y-axis. And if you look at most of the data, there seems like there's a fairly common relationship between height and weight, which is the taller somebody is, in general, the heavier they get. But then there's this one outlier, right? And if you guys are familiar with Star Wars, you probably know who that character is. But this is a way to visualize and say, oh wow, one of these doesn't sort of fit the mold. So who do you guys think this is?
Jabba the Hutt.
Jabba the Hutt. It's not.
Darth Vader.
This Vader probably is super heavy. He's all metal. No, but it is Jabba. It's Jabba the Hutt. And there's Jabba. Picture Jabba eating something. I think he's eating one of those little frog dudes. So those are outliers, right? So you can visualize, if you visualize this data set, you can, there's a trend, and then you can also see outliers. And then you can try to figure out, why is this guy an outlier? Well, it turns out that the species is not very tall and incredibly heavy. Anyway. So let's talk about visualization. So this is all about this ggplot thing. And this is a quote from John Tukey. So John Tukey's kind of the father of visualization. He's written a bunch of interesting books about how to visualize stuff. And he's he's very hot on graphs. And this is just a definition of data visualization, right? It's just like visually representing data. And we're going to use R for visualizing the data. And we're going to use the specific package in R called ggplot2. And it's a funny name. So we'll talk a little bit about what it means. Okay, so ggplot2, it's part of the tidyverse. The GG stands for the Grammar of Graphics, which is from this book called The Grammar of Graphics by Leland Wilkinson. And let's pop to the next guy. Does anybody know what this symbol is? You math people? It's a set theoretic way to say what ggplot is. That's anybody? That means element of. So ggplot2 is an element of the tidyverse. That's a very geeky way to say that. That's ggplot2 is part of tidyverse. Here's a cool picture of the book, and this is like, we're going to use the grammar of graphics to talk about sort of how we use these different sort of layerings to build up a graph from data to the end sort of picture. So if we look at this guy, this is we're going to deconstruct this, all the bits in this ggplot. So we've seen some R Markdown that has ggplot in it, and it has a bunch of stuff that we've talked about a little bit. But let's just I'm just going to reproduce this quick to make sure that it actually does do what I want it to do. Boop. I'm going to run that thing. Gives me this graph down here. Height's on the x-axis, weight is on the y-axis. Each character is a point, and you can see there's the Jabba outlier. It's got a title, and it has this warning message too, which says I've removed 28 rows because there's missing values somewhere. So that means that there's 28 characters who don't have either a height or a weight. Let's go back to the slides. All right, so lots of questions, right? Like, what's doing the plotting? What data sets going to get plotted? What variables am I mapping? There's a lot of things I have to define. And then what does this warning mean? I already told you what it meant. But when you see the warnings, generally they're fairly descriptive. And then you want to go back in the data and look and see, like, really, are there really 28 rows that don't have don't have data in them? Well, let's take a look.
Warning is one more time.
Yeah, sure. So the warning message says the ggplot looked at the data from Star Wars, and it said it couldn't do anything with 28 rows. And we're going to look and see why. So let's go into viewing Star Wars. Oops, Star Wars. I'm going to do view, and that's going to pop this guy up. And in fact, I only care about, let's just do this quick. just WH. So I'm going to say, and I'm going to just say that's Star Wars. I'm going to subset it. All rows, and I'm just going to, I'm trying to make it easier, but it might make it
Wait, sorry,
complicated. Yeah,
I'm confused.
okay.
I think I missed too much earlier because I don't know what I'm supposed to be writing in. Like, how am I supposed to know
Oh,
what?
you're just try and follow along. You're not supposed to copy any. You're not supposed to be. You don't have to do these things. I'm just trying to illustrate them, but you can if you want.
I was trying, but I just didn't.
Okay,
Yeah, I
well,
don't know how to do it either. So either show us how to do it or just
Let's
do
do
the
it.
slides. Is
No,
I lost a
do
lot
it.
of time too trying to follow you. So
I'm sorry. Okay, so let's do it though. I want everyone to be up to speed. So the first thing you want to do is, so you have a blank RStudio open.
Yeah, I did the tidyverse thing.
Oh, good. So you installed. Did you do the install packages of Tidyverse?
Yeah.
And then you
I
did
didn't.
library.
I didn't. I don't.
Okay. So write install.packages and then Tidyverse in quotes. And you want to put that in the console. You want to put it down
Yeah,
here.
I'm not following you.
Well, in the console, you can write install.packages. And then you can, like this line. Can you read this? Is this too small to read?
You got that's the functions. You have to write what you're installing.
What are we installing?
Tidyverse, which is like
Tidyverse.
it's got a bunch of functions and the data that we're using. So just start writing tidyverse and then select it up here. It's going to install it, and while it does that in your document, you can write library tidyverse. And that's going to open the library of tidyverse in the document. So once this finishes installing, then you can run it in there. You have to do it in quotations, I think.
The install packages has to be, yeah, the Tidyverse is in quotes.
And then because this is a document you can't enter, enter doesn't do anything. Run is what runs it, and then the console's entered. But it's a bit annoying. And then you can do all the data stuff. So if you just want to look at it, you can just see.
So I couldn't I just selected it here?
I guess.
So let me know when it's installed. Whenever, yeah. If you want to follow along, then yeah, everyone should install the
I think I'm
Tidyverse.
gonna look along.
I know. Where can we
Sort of
find
like
a
us
untitled
choosing
one?
part of it.
What?
To find an untitled project, say new project and then new RStudio project.
Oh yeah, but in the new project, to open up the thing above the console, like you press you clicked on untitled one. That
Oh,
opened the tab.
here, you can say file, new file, R script.
Oh, okay.
So let me know when you're installed, when your Tidyverse is installed, and then we can go on. I'll wait. We can wait just a little time, take a minute, couple minutes. So you want to do it too? Just install your package Tidyverse and then do the library, and then you can follow along too.
Okay.
It'll take a couple minutes.
So, wait. To install I just did library and tidyverse in parentheses in the top box. Is that right?
In the top left.
Yeah.
Did you install your packages, Tidyverse, already?
Does that mean like a bunch of stuff came up on the console part?
Yeah,
Like-
if you had typed in install dot packages and then.
Yeah, binary
Oh, you,
pack-
okay. Yeah, so if you have this guy, all you have to do is click the run button in library tidyverse, just boop, and that will run it'll import the library.
Is that the last step?
Yep,
like-
and then and to know that it's been installed, just like type Star Wars, like run Star. You can either like run it from here, or you can just type it right into the console. Star
Wars console?
Yeah, just type Star Wars into the console, and you should get like a little data display.
Oh,
It
so
says E.
2 words?
Nope, one word, Star Wars.
Oh. Okay. And something should pop. Yeah, it pops up.
Okay, yeah, and so you can see Luke Skywalker and C-3PO.
Wait. Do I press enter?
Yep.
Oh yeah, yeah. And then that's the data set.
Yeah, yep. So
Uh-huh.
you got it. Cool. Awesome. And then you can, if you want, you can type glimpse and then Star Wars in parentheses. Like, I don't know if you can see that in the small screen. But you could just type that right into the console, glimpse.
Oh, and it's okay.
And then Star Wars. That's the same thing as running something from an R script, is typing it in the console. They're basically doing exactly the same thing.
Wait, so what's it doing when I type in the top left part?
It's just like a text editor, but then you have to execute it, and so you can either click the little run guy, or you can actually highlight it and you can copy and paste it into the console.
Okay, I might be like going like asking, but what you already went over.
That's
But
fine.
how
Yeah,
do I
please do.
decipher what to put in which box?
Well, so the top left one is like a text editor, and that's just where your code will go if you want to save it. But when you execute it, it'll all execute the console. So
Okay.
right now, let's just do it like this way. Like in the top left is your R script, and like line 7, do this in the console. Do question mark Star Wars, and then you'll see the help for Star Wars.
Glimpse, and then in parentheses Star Wars.
Yep, or glimpse. Yep.
Okay. And then
You see the rows and columns and the names and stuff pop
oh
up.
shoot, I did that in the console, but it worked.
Yeah, that's fine.
Okay.
And you can, if you go over to the right, to the top right, you can see what you've typed in before. If you you can go to the history tab, and you can see all the things that you typed. If you want to type them again, for example. Okay. Does everybody have their Tidyverse installed and loaded? Does anybody not have it done? Want to raise your hand if you have it done? Where are you, Jackie? Do you have
Yeah, I have it done.
Oh. So everyone has it done. So you can run some of these things if you want. Like you can see the number of rows in Star Wars if you want by just saying in row Star Wars. Okay, so I'm going to go back. If you want to execute this here, let me. So we're back on back on ggplot now of Star Wars, and I'm going to copy and paste this into the chat if you guys want to execute it. And then we're gonna sort of just like understand each little bit through the slides. So the next slide is basically ggplot is the main function for ggplot2. So you're always going to start with ggplotting. And then the plots are like created in these layers. And the first part is like defining what the data set is. So the data set in our case is Star Wars, right? And then there's these things of like mapping, and the mapping is like going to map your, like, what's your X variable mapping to and what's your Y variable mapping to. And then the next part of that is like, how do you want the plot to come out? So we've used geom point mostly, but there are other like geoms like geom line, and you can make bar charts and other things like that. We already talked about the library for the tidyverse, but so for the Star Wars data set, like what would, I already answered the question, what would the data set be? But so for the mapping for the plot that we just looked at, what are the X and the Y variables?
Height and weight.
Height and weight, yeah. So if we look over here, you can see height and weight are there, and height and weight are also, that's interesting, it's mass. Oh, it is. So X is mapping to the height variable and Y is mapping to the mass variable. And if you look in your data set, you can see there's a height variable and a mass variable. And those are the things that we're plotting. And that's what ggplot is pulling it out from. All right. Okay, now we're any questions up till now? I don't know if you guys are.
Well, that you add geom point or whatever. What does that mean again?
That says what kind of
what kind of graph?
What kind of graph do you want? Like the point is like a scatter plot where you're just going to put points down at X and at Y, but you can also make a line or a bar chart.
Yeah.
Okay. Okay. So I'm gonna move on. But is there, Shamil? Did you have a question, or your hands just up from the last time I asked you to raise hands?
Oh yeah, I just had it up.
Okay. Okay. Let me quickly go through the why do we visualize. This is similar to the homework in terms of like the point of it. So this is a thing called Anscombe's quartet, and it's 4 different data sets, and basically this is the whole data set, and basically there's 3 variables. There's set, which has a 1, a 2, a 3, or a 4 Roman numerals, and then xy values, right? And the interesting part is if we look at the summary statistics, the mean of X and the mean of Y, and the standard deviation of X and the standard deviation of Y, and then this R, which I think is correlation coefficient, they're all identical for this data set. So if I didn't visualize, I would think, oh gosh, these data are all really similar.
Didn't we just learn this already?
We did, yes.
Okay.
But the data is different data.
Okay.
Yeah, this is basically reinforcing what the homework said. And so you can have very, very different visualizations and have exactly identical summary statistics. So that's just why we visualize. So it's just trying to beat it into your head. And there's other reasons why we visualize it. And here are some examples. This one's a tiny bit creepy, but they did a survey, and then they said, you know, how old were you when you had your first kiss? And so so this is a histogram of answers, right? So, and the answers range from like 1 to 20. So if you were looking at this like with a critical eye, you might have like, does anybody have like any observations about the data and like what it might mean? Like, is it weird that some of the numbers are pretty small? Like,
Yeah.
So, yeah, so what would you?
That's
I mean,
super creepy.
and what? So this was a survey at a college, right? And this is how people answered, and there was no context. So
Okay,
Well-
yeah, so it could be a kiss from your mother, right?
Right.
yeah,
Probably Tom
Hopefully.
Brady.
yeah. So one way to interpret the results is that people had a different context in terms of what they meant by kiss. Like, so if you're 15, that's maybe a romantic kiss versus if you're 1 or 4 or 5, maybe that's kissing your mom, right? So this is an illustration of how if I do a survey and the context is sort of misconstrued or taken differently, I might get very different data. Here's another example. This one's a little less creepy, which is Facebook visits. Like, so here's another a query for a survey of college students. How many times do you go on Facebook a day? So this one has a little bit of a different kind of, you might take away something different. So does anyone have sort of any comment about this one? Like any observation? Like, for example, the lower values versus the higher values.
They probably were like saying, "Oh, I probably go 100 times a day," but they took it literally.
Well, right, exactly. So so one thing that you might see is that for the very high numbers, people are being rounding a lot because they go on so much, they're like, oh, it's 100, right? They pull a big number out of the air and it's it's an easy number. Whereas the people who might only go on a few times a day might be a little bit more precise in the way they count. So that might be one takeaway. The other one is a lot more people go on. So from this data, it looks like a lot more people go on fewer, which I don't know. Well, it's Facebook. Maybe it depends on demographics, I guess, if the people doing reporting. But the higher the number, the more concentrated, the less variation there seems to be in the reporting of the data. That's kind of interesting. Okay, so that's the first set of just the big overview of ggplot. In the next section, we're going to go into a little bit more detail about the different layers in ggplot, but I wanted to come back to RStudio quick and just see, does anybody, I hope I didn't confuse anybody with going over to the R project, but I think it is actually useful to go through and to just sort of like explore the data a couple of different ways. So if you're stuck on anything, let me know and maybe we can do a quick clarification. So,
Do we want to really get it, or are we gonna see it in the labs and in the other stuff? Do we
we'll
want
see
to
it
just
more.
kind of get a gist of it, or do you want?
It's up to you. I mean, yeah, we will see more of it. So you don't have to go through, but if you're stuck and you wanted to go through, then we could clarify now. But it sounds like maybe not. So we only have 20 more minutes. So I'm gonna I'll go on to the second slide deck, and then we'll end after that. So this is the second deck, which is about like the high level sort of dissection of the ggplot layers. So let's just dig right into this one quick, and then we'll end.
So the command is called ggplot, but the package is called ggplot2.
Yeah, so the
Okay.
library, yeah, it's ggplot2. See, it says ggplot2 there.
Okay.
But yeah, the actual, probably because there was a ggplot1 and it didn't work very well, and so they rewrote it. That was a lot. Anyway, okay, so what does this say? Anyone decode the emojis here?
Ggplot loves penguins.
Bam.
That's what I got.
ggplot loves penguins. So we'll get there. So this is just a reminder, ggplot2 is tidyverse's data visualization package, and it's based on the grammar of graphics. And this is the basic structure is ggplot, data set, what's my mapping for my x and y variables, and then geom, use a geom of some kind in order to say what I want to, do I want to do a line or a points or something?
Can I just digress for a second?
Sure.
So the tidyverse is that like owned by somebody and comes out in regular releases, or is it like a group source thing that everybody improves on and it's like a
It's
crowd
open
thing?
source. It is open source, but it's maintained by this one guy called Hadley Wickham. So people do, he does all the maintenance, but people they contribute to it. It's open source in the sense that you can read it. It's all publicly available, and you can, like, if you have a bug fix, you can say, hey, Hadley, I made a bug fix. But he does most of the development of it.
Okay.
So is ggplot2 always part of the tidyverse, or isn't it a separate package?
It is a separate package. So it's the tidyverse is basically a collection of a jillion packages that they've
Okay.
wrapped up. Yeah. So it is separate now. Yep. Just like dplyr and all the other ones.
So if you
and
load ggplot2, it could be a different version than if you load tidyverse.
That's true. And I can load it separately. I can say library ggplot2 and just load ggplot2 without all the other tidyverse stuff coming along for the ride. And
But
that
they
takes
can
up-
be different versions?
Yeah, you have to be a little careful with that. There's a thing called, which is a little bit of a diversion, but CRAN is the comprehensive archive network, and this is where all the official supported latest versions of stuff come from. And generally, you don't version these, or if you do, there's only a couple. But then you can go to GitHub and get much more specific versions of things. But generally, you don't want to worry about versions unless, like, you've run into some weird bug.
Okay.
Look, the latest release is named Funny Looking Kid. That's funny. They name releases with names, like Jelly Bean and stuff, but I never heard of Funny Looking Kid. Okay, let's go back to ggplot. So ggplot, next slide. So ggplot loves penguins. So Palmer Penguins is a library that is a common library that people use. That and so you can look at the data set here, and people use it for this kind of stuff, just for looking at data and stuff. So I'm going to do this. I'm going to go over and I'm going to load in Palmer Penguins in RStudio. I'm going to put it into my R and I'm going to run it. And oh, it doesn't like it. That means I have to probably install it. Installed it into the library, and I'm just going to make sure I can do this. I can glimpse this, and you can, again, it might be interesting for you to glimpse it. You don't have to. And so this is just like, if you wanted to go get it, you can just install it through the library, and then you can see those data. And it's got these 8 columns: species, island, bill length, bill depth, flipper length, body mass, sex, and year. So that's what this is saying here. So there's these 3 species, and they're all in these different islands. I think I put the Nordic or something. So here's a super cool, nice illustration of a relatively complex ggplot, because it's a scatter plot, right? It's got X's and Y's, and I'm plotting bill depth versus bill length. And they're color coded, and they're color coded by species. So red is Adelie, green is chinstrap, and the blue is Gentoo. And they kind of cluster, interestingly. And then there's this nice title, and then a nice subtitle. And you can look at the code for that, and it's all this stuff. And we're gonna dissect this, but it's basically it's doing a ggplot, get the data and the mapping, and then the geom point, because it's going to be a scatter plot, and then a bunch of other stuff for labels and stuff. And let's just keep going, and it's going to rip it apart a little bit. So let's look at the code. I'm going to so we're going to start with the penguins data frame. So if you just did ggplot and data equals penguins, this is what you're going to get. You're going to get an empty looking thing, and you're going to be really disappointed. So like, what the hell? I just said ggplot of data equals penguins. But that's because you didn't finish the ggplot grammar. So the next thing you're going to do is you're going to say, okay, well, now I want to do mapping, and I'm going to define my X label, my X dimension, I mean, and I'm going to pull the build depth millimeters as my X. And so anytime I've got X equals, this build depth millimeters has to be like a variable in the data set. Otherwise it won't find it. And I'm going to do the same. I can do the same thing with Y. So I'm defining my X dimension and my Y dimension. So it's a build depth and build length. And then the next thing I'm going to do is so this is a little bit weird because there's a little plus. Oops, shit, I didn't mean to do that, sorry. The little plus here doesn't show up unless you stretch this guy out. You have to have the little plus there. And now the next thing I do after my definition of my data set and my mapping, hold on one second, I'm sorry. Here, I have my data set and my mapping for X and Y, and then I'm going to say, now plot these as points. And so it plots all these as points, but it's kind of a big mess because I can't differentiate of the species because I don't have that in here. I don't have anything about species in here. And so one thing I might do is in the mapping, I might say, well, I'm going to map the color of my dot to the species variable. So species is a column in the data set, and the color is mapped to species. I don't know if you need the U. I think you can do with or without the U. And then, so now it's starting to look pretty cool. Now I can differentiate my 3 different species. The legend comes up by default. I can suppress that later if I want to. And so it's looking pretty good. The next thing I can do is I can start adding a bunch of labels. So I'm going to add a title, and then I'm going to add a subtitle, and then I'm gonna write in. So I'm going to change the X and Y label. So by default, the X and Y labels are the actual variable name, but that's not a very pretty variable name. So I can override that and write in whatever I want. In this case, it's just sort of capital B, and there's a space between build and depth, and I can say the units are millimeters, and it just looks prettier. So I can do that, and I can keep going, and I can say, well, oh, color equals species. It allows me to label my legend. So if I didn't do that, it says species is lowercase s because that's the name of the variable, but I want it to be uppercase because when you want to have everything uppercase when you name it for graphs. And that's a reproduction of that. So we just went through that. So hopefully that's clear, is that all of these things have a different meaning. Any questions on that? Does that make sense?
Clarify for myself.
Yeah.
So ggplot, the stuff you're putting in there, that's gonna be like what X and Y is and the kind of graph. And geom point is like how it's set up.
So geom point says that's kind of the type of the graph. The geom point says plot each of the points here. You could do like a geom line, and then it'll try and draw a line graph. It doesn't work for this data, but if you wanted to make like a time chart of temperature or something, you could make it show up as points or as lines.
Oh, so, okay, wait. So ggplot's like data and which data is which, like X and Y, and then the geom point is like how it lays out.
Yep, exactly. Okay. Yeah, and so in the mapping, if I'm gonna get any of the mapping stuff from the data, I would put it in the mapping AES. So I have X and Y, but I also have color, right? So the color, I'm getting the color from the species variable, and so that's where I put that data.
So it's a little confusing because you have an open bracket at the top in ggplot and the closed bracket at the bottom. So it's all one big command. It's all one big ggplot command.
Hold on. It's not. Let me copy and paste it into RStudio because it's too. The wrap's not working very well. So this is.
Okay, you're adding. You're using
the little plus sign is the way that it's the syntax that they use. So, but this is a complete statement.
Yeah. Okay.
But if I just ran that, I'm going to get garbage. It's not going to do anything. Here, let me just run that. You get this empty guy with the X and the Y. There's no data because you have to add the plus to the G on point to get the actual data to show. It's just the way they do it. Sorry?
What's the difference between color species in GM plot and in GG plot? Like, what does which one do?
Okay, so let's do this. I'm gonna plot all of them. And you can see that the color species is here, right? The species.
E is the GM plot.
Yeah, so let's just remove the color species bit and rerun this, right? Then you won't see the, actually it might puke because of color species.
Okay.
So it hasn't differentiated the species by the color of the data points.
Okay.
That's what color species does. This thing's just a label. Does that make sense? A little bit?
Yeah.
Yeah, okay. We'll go into more detail. Let's see. So there's other things that you can do. So once you've done your basic thing, now you can there's these different color scales that you can do. And this is a little odd because I'm mapping color at the top, but at the bottom I'm saying, look, I don't want to use the default color scheme. I want to use this special color scheme for people, so people with color blindness can see the differentiated colors too, because you've got sort of the different, you've got yellow, which is very light, and then green, which is sort of middle, and then the purple is dark. And so if people don't see colors, they can still see this by adding this extra bit. And so you can change the color scheme. There's a bunch of different color scales that you can add, and this is just one example of it. That's just another thing that you can do after you get the basic structure of the ggplot done. So that's the end product. So there's the plot. The code is what we just went through with all the parts, and then the narrative. I guess you start with the penguin's data frame, and then you're going to map build depth to the x-axis. You're going to map build length to the y-axis, right? That's this. And the next part is represent each observation with a point and map the species of the color to each point, right? And that's species mapping plus laying it out as points. And then you're going to do a bunch of labeling. You're going to label the title and the subtitle and the x-axis and the y-axis. You're going to put in your own text for that. And that's all this label stuff. Labs, it's like labels, all these different labels. And then the last thing you're going to do in the narrative says use a discrete color scale so that people with common color blindness can actually also see the difference between the different colors. And that's this YaRDS color scale at the end. So that is oh, okay, there's one more thing. So let's talk about, let's see. Oh, this is about simplification. So you don't need to say this is it. Oh, I didn't mean to do that. Sorry. Sorry. Argument names. So in general, you don't have to say data equals. If you put the data set in the first thing, you don't have to say data equals. I like to, because then I know exactly what I'm saying. But this is a simplification if you want to make it a little prettier. But I don't recommend doing that. I would say let's not do that. And let's say, what mapping. If you say, mapping equals AES, and you're doing a mapping here, versus just like putting it in, and it's implied based on the order. So don't do that. I don't recommend doing that. Okay, let's talk about the aesthetics real quick. So we can change a lot of stuff about the points. We can change the color or the shape or the size and even the transparency of the points. So just for example, right, I've changed the color here. I can add another one that says change the shape, right? And so now I have the color as species, and the shape I can say, oh, the shape, use the island variable, and it's going to change the shape based on the island variable. And now I've got more information. It's getting a little bit too crazy, but I've got different information in here. I've got the species is purple, green, and yellow, but the different islands that these guys are on are in these different ones. So there's a lot of Dream Island is triangles, and the square is Torgerson Island. So you can encode more data on there if you want to. And then if I wanted both color and shape to be mapped to species, like the triangles will all be chin strap and they'll be green, I can do that by mapping these color and the shape to the same variable. Makes sense? Somebody's got a lot of background noise. I don't know if you could.
Could you just go back so we could see the difference?
Yep,
Okay, so shape was island before. Okay.
yep. And so you get 2 legends for that, but that's super busy and hard to understand. But if it's smart enough to know it's 1 legend. It'll change shape and color. Yep. So let's just go. We'll see a couple more variations of this. So you can change the size. So you could have the mass, the body mass, as the size of the point. So shape and color map to species, but in here size, the bigger ones, the bigger the dot, the bigger the fatter the penguin. And then the next one is flipper length. So I can the alpha blending, like the transparency of the dot. The more transparent it is, the shorter the flipper length. Again, I wouldn't do this, but it's just an illustration of the things you could do. Sometimes it might make sense. And then, okay, this is what Jackie and I were talking about this a little bit yesterday. The difference, what's the difference between like mapping and setting? And so if I only want to set the size of my points to 2 and set the transparency of all my dots to 0.5, I would put them into the argument of geom point, like here, that says all of the dots are going to be too big and they're going to be 0.5 transparency alpha. But if I want to map them to data, if I want to make it data driven, I have to put it into the aesthetic mapping. This should say mapping equals, and then size equals body mass, and alpha equals flipper length. So that's a differentiation that you might get bit by, but you come back and sort of.
What's alpha again?
It's transparency. So if they're overlapped, you see that there's these 3 guys that are. I don't know if you can see my mouse, but when the dots overlap, they get darker. See that? And so you can. It's a nice indication. Like it gives you kind of a heat map. If you've got a lot of dots that are over top of each other, you can see that if you have a transparency variable. This is more complicated because there's transparency of a variable, and when they overlap, the transparency changes. So it's just an illustration. It's not a very good illustration of a good graph. On the right, it's a little bit more clear because all of the alphas are 0.5, and so you see when the dots overlap, they get darker, and so you can kind of see. Like otherwise, if you have a bunch of dots over top of each other, you can't see. You kind of don't know that there's a cluster of them or not. So it's a way to see sort of a little bit into the 3rd dimension. Anyway, that's mapping and setting. We'll come back to it if there's like confusion. But so this is just a summary of mapping versus setting. So mapping is you're determining some setting based on the value of a variable. And a setting is you're just setting the aspect, the size or the alpha or whatever, and you're not basing it on the variable. That's all that means. Usually you'll use mapping because you get more information into the graph that way. We can play with that. Okay, now we're on to faceting. So we did a little bit of faceting in homework 1. And so this is what facets are. Hopefully you remember. I could have. So it's a bunch of little plots all on one big plot, and each of the little plots is exploring one subset of the data based on one of the variables. And so, for example, here we have facets, and this facet is a 2-dimensional facet. In our homework, we had a 1-dimensional facet, and the facet was basically called data set, if you remember. This is 2-dimensional, which means the rows are different than the columns. And so my rows are Adelie, Chinstrap, and Gentoo, which is the species, and my columns are the islands that those penguins live on. And if we look at the code for this, you can see that when you do the facet, it's rows. I want these, I want the rows to be species, and I want the columns to be the island. And that's what this means, this little tilde. Oops, I'm sorry, I keep doing that. The little tilde is just a separator between rows and columns in the way that this is written. It's just how they do it. So they use facet grid. Last time in the homework, you used facet wrap, and they're slightly different. This one lays out a grid of X by Y, and in facet wrap, it was just like any number of facets. But this one specifically says I want rows and columns, and so it'll always like lay out as a square. So there's three values of of each of these variables, and then, so rows are species, yep, and columns are the island. So there's other ways to do the faceting. So we're just gonna go through a few examples.
You're at time.
Yeah, we're at time. Let me just finish up. There's only a few more slides. So if I want to do species and sex, so species again is rows. My rows are species, and my sex is female, male, or some NAs because the data wasn't filled out. Or if I want it the other way, my rows could be sex, female, male, and NA, and my species can be in columns. And then the wrap says, okay, I just want to do species. Just lay out all the species, and it'll wrap where it has space to do that. That's what the wrap means. It's only one dimension. That's looking at. And then I can specify the number of columns. I'm going to zip through this.
Where was the frame thing that we did before?
You did facet wrap before?
No, up in ggplot, wasn't there like a frame size?
Oh, that wasn't part of ggplot. That was part of the little R chunk that says the figure has to be this width and this height. That wasn't
Okay.
part of ggplot.
Part of the R chunk, okay.
Yeah, it's part of R chunk. So this is just a summary of facets. And you know, the way to learn this is to play with it, you know, I think the labs will have some of this in it. And then you can do colors. Again, you can do, this is just fancifying, right? So you can have facets and you can have all these other aspects with the color and the, you could add size and stuff. And there's a bunch of options. What is this guides color equals false? Oh, you can turn off the legend if you want more space. And that's it. So I kind of raced through facets, but there's lots and lots of options. And I think that the way to learn them is just by doing examples of them. And we'll do that in the homework and in the application exercise. All right, so that was those two slide decks. So that took an hour. And then so next week, we're going to come back and we'll do the rest of the slides, and then we'll dive into the application exercise. So good. There isn't no homework because we're kind of out of phase. So the homework, you can play with it if you want, but the homework's not going to be until, we're not going to go through the lab and the homework until next week. So I guess you get a break. All right. Thanks a lot. Appreciate it, everybody.
Thank you.
See you next time. Bye-bye.
Okay, thanks.
Thanks.
Bye.